So have you seen these two things during the lecture? Conduction and induction? Yes. So you can charge objects using two methods. One is conduction and the other one is induction. So during conduction, there is actual contact. But the charged object is touching the neutral object. So charges will move through conduction and it will leave the final object charged. So that is one way of charging. The thing is induction. So what's happening during induction? Do you contact the two objects? Do they touch each other? No. You just bring one object, the charged object, closer to your, this is neutral object. Neutral means what? Neutral means it has equal positive and equal negative charges. So when you bring the charged object closer, we know opposites attract, right? Since this is negative charges don't like negative, so they repel and go far away from this negative charge. That is why relatively this side will be negative and this side will be positive. So if you just take this away, this is not going to be charged. So to charge by induction, you definitely need to ground it. So what happens when you ground it? So when you ground it, what happens is, so you can see that because of this negative rod, positive charges are kind of like bound to this corner, right? They're like they're attracted to this negative charge. But negative charges, no one needs it, right? So negative charges are free to move and go to the ground. These positive charges are not going anywhere. They are attracted to this negative one. So this negative charged object is taking care of these positive ones. And when we ground, only the negative ones go. So once you take the ground and take the charged object, your final object is left charged. So I'm pretty sure that you know these two scenarios. Okay. Is connection to ground necessary? Yes. So when you are doing induction, grounding is necessary. Let's say you did not ground, what will happen? So you have this, you do this, and you take this rod away. What will happen? Initially, they were like kind of separated. Once you take this off, they will again spread out evenly, right? Still, this is neutral. So if you do not ground, nothing will happen. They will stay neutral. This will stay neutral. Okay. So grounding is necessary to charge through induction, but in conduction, you just have to contact the two objects for a moment. Can you answer the first question? Are both the above processes be applied to charge an electroscope? You remember electroscope, right? From the lecture? The gold leaf electroscope. There's something like a bottle like this. So your answer is correct. Yes. It's not only valid for a sphere like this. It's valid to charge even an electroscope. But the process is the same. So when you need to charge the electroscope by conduction, you touch the two objects, right? When you want to charge it through induction, you bring the charged object closer and then ground this for a moment. Okay. So yes, the answer is this is yes. And let's say a question says, instead of grounding, let's say they say you touch the object, like using your finger, you touch it. What will happen? It's still grounding, okay? Because you are huge, right? Charges will go through your body and be ground. Okay, so part 2. That's my main question. Tell me the main differences between the two methods. The method is different, that's true. The conduction is contacting, there's some contact. In induction, you don't touch. I mean, touch means the objects don't touch each other. So the method is different. What else? What about the final charge? Can you look at the two diagrams and compare the charge? So same charge in conduction, opposite in induction. Can you see it? So for both the scenarios, we used a negatively charged object to charge our object, right? So we used a negatively charged object, we used this to charge the sphere. But during conduction, we got the same charge, negative, negative. But during induction, what happened? We used a negatively charged object, but our end result was positive. Can you see it? Nice observation, right? Okay. So during conduction, you get the similar charge. If you use negative, you get negative. If you use positive, you get positive. But during induction, you get the opposite charge. If you use negative, you get positive. Sorry, positive. If you use positive, you get negative. Clear? Okay. Since you know the difference between the two, now I want you to do these two problems. These are two multiple choice problems. Do it and tell me the answer in the chat. So I'm going to draw what's happening. A sphere A carries a net positive charge. So we have A, and they are kept on insulating table. So this is the table. And sphere B is neutral. Okay. They are placed near each other on an insulating table. So they are just next to each other. They are not touching, right? They are not contacting each other. So what happens when two objects are close to each other? Negative charges will come to this side, positive charges will come to this side, right? And what do? Then they ground it. So once B is grounded, what happens? So this is the opposite of what we did, right? What we did before. When we ground it, so these negative charges are kind of like bound, because this object is positive. these negative charges don't want to move. They want to stay there because this is kind of forcing it to stay in this side. But no one needs these positive charges, right? So what happens when your ground is negative charges come from the ground and neutralizes these positive charges. You know that only negative charges travel, right? Negative charges are electrons. So electrons can travel. Positive charges are protons. And protons cannot travel. So here what happens is when you ground it, negative charges from the ground comes and neutralizes these guys. So they are neutralized. So you don't have any charge here once it's grounded. So let me erase it. Initially we had positive. So just draw it. And when it's grounded, they get neutralized. And once you remove the ground, this object has negative charges now, right? So this is B. So your answer is C. Sphere B is now negatively charged. So you can draw it and get the answer like I did now. Or I just did this way to show you what's actually happening. But you already know the answer, right? From what we did before. We know if it is induction. Induction means opposite, right? During induction, we got the opposite charge. During conduction, we got the same charge. So I have a question. If they are near each other on an insulated table, wouldn't it be conduction because electrons can go flow through the table? So conductors and insulators. So I just read a question in the chat. So there are two things, right? Conductors and insulators. So insulator is a material where charges cannot flow. That is why it's called insulator. For example, a piece of wood. Charges do not flow. For example, wood. Conductors are like metals. They can transport charges. Charges can flow through them. So since this is in an insulated table, that means what? Charges cannot go from this to this. So that is not conduction. Okay. So let's say they change the problem. Instead of insulated table, they used a metal table. Then it's a very tricky problem. It's like confusing you. They are not touching the two spheres, but they keep it on a metal table. Then it will be conduction. So if it's induction, opposite, conduction, same. Since this was induction, it should get the opposite charge. A was positive, therefore B should be negative. So if you don't remember this, it's fine. You don't have to. You can do this and see. Okay. The next question, how can a negatively charged rod charge an electroscope positively? We know, right? Through conduction, it's same. So it cannot be conduction, right? We know if it was negative, conduction will give you a negatively charged object. If it's induction, opposite. So through induction, you can do that. So conduction gives you the same charge. There's nothing called deduction. We know we can do it. So when you learn things, try to always compare when there are different methods. Then you can find easy methods to do problems. And also it's easy to study. So I'm pretty sure that all of you went to the lecture. But maybe not all of you saw the difference. So it's always compare the two. Then it'll be easy. Okay? Okay. So here's another problem. Tell me the answer. The answer is C. So when you are doing these problems, the most important thing is figuring out whether it's conduction or induction. So they say originally neutral electroscope is briefly touched with a positively charged rod. It's conduction, right? It's conduction because it's touched with the rod. So we know conduction means what? Same charge. Positive, positive. I can draw what's happening also. So they have a neutral thing, electroscope. So here's your new electroscope. They touch, but they actually touch a positively charged object. So what happens? Through conduction. This thing is metal, right? This is metal. So charges will go and this one will get charged by positive charges. So induction is the hard one. Conduction is not. Conduction is just same charge flows. Okay. So before doing this problem, I will quickly go through. We have time. I will quickly go through what's happening in an electroscope. So in an electroscope, we have this metal thing. So this whole thing is made up of metal. So whatever I'm coloring is made up of metal. And then you have two gold leaves. Gold leaves. You know leaves. There are two pieces of gold like this. So that is what's here. So from here to here, it's all metal. So when you charge it, for example, let's say we contact it with a positive object. What will happen? This thing is going to get positively charged, right? So this whole thing will get positively charged. So these two metal plates, metal leaves, when they are positively charged, what happens? They're like this, let's say like two fingers like this. Okay, when they are positively charged, they repel each other. So they don't like each other, right? They repel. That is why when an electroscope is charged, these leaves are like this. Okay, even if it's negatively charged, the same thing happens. Okay, another example. Let's say we have an electroscope. We have two electroscopes. I charge this one with a bigger charge. Let's say 4Q. I'll just use the letter Q. Think that it is a bigger charge. Okay, 4 is big. And this one I'm going to charge it by 1Q. What will have the higher deflection? Deflection means the distance between these two. What will have more distance between the two? A or B? A, right? Yes, it is A. Why? Because more charge means there's more charge. There's more charge on these two leaves. So they don't like each other even more. They try to repel. Okay. So when the charge is less, still there is repulsion, but the deflection is not as high as this. So the distance between the two leaves will also tell you the amount of charge you have in the electroscope. Okay. So with that in mind, I want you to do the last problem and tell me the answer. The answer is correct, B. Let me explain it. So let's see what's happening. Okay. So we have electroscope. A positive object touches the neutral electroscope and then leaves separate. What will happen? That means this is going to be positively charged, right? So the whole thing is positively charged. That means these two leaves are now separated. There's a deflection. Then what do? Then a negative object is brought near the electroscope but does not touch it. So what they're going to do is they're going to bring a negative object. So what will happen? Let me use a different color. So when you bring a negative object, positive, so we know positive ions don't move, right? Actually, the negative stuff moves, and that's the thing. So when this happens, the negative ions, electrons, negative charges closer to the surface leaves. Leaves means it tries to go further away. So more and more negative charges, which is in the original object. So we know there are always equal positive and negative, even if something is neutral, right? So negative charges, which was here before, goes towards the two leaves. So what will happen to the two leaves now? Initially it was positive, right? And now, because of this induction, not because of this dot, negative charges will come and kind of neutralize these, right? So let's say these guys get neutralized. So the total, what will happen to the total charge? The total positive charge will reduce. Yes? Does it make sense? Yes. So the total positive charge will reduce. It is only because when we bring something, the same charges try to repel. So negative ones go down more. So the total positivity reduces. So the total charge, when total charge reduces, what happens? Less deflection, right? So similar to these two cases. When the charge is less in the two leads, the deflection is small. So they will move closer together. We don't know how close it will come, but still it will be more closer than before. Okay. So I will see you on Wednesday, and make sure you go through the lecture and come.